All right, yeah. So again, every day is a laptop day. We're going to be looking at some more Python, and I think we should be able to transition into the API related stuff, finally, yeah? That is if you guys are comfortable with the stuff that we've been covering so far, the Python stuff we've been covering so far. Or have any questions that I need to go over regarding the Python stuff? Anything difficult, anything I need to do again? There was something I wanted to demo, if I can get it working, hopefully. One sec. So hold on. Give me one moment. In the meantime, you can start setting up your projects for your, what's it called? Is that your theme song? Walking over glasses and music playing. All right. All right, so this demo, in the group chat I was asking if anybody play Minecraft, and I said that I promised that it's a IoT related thing. So what I want to demo, and I tested this last night, but I'm not at home anymore, so maybe it's not going to work, is how we can basically design our IoT platform where anything can be a client. Yeah? So what I'm going to be showing is how I can use my microcontroller as a client. This microcontroller is an ESP32C6. It's different from the ones that are going to be making available to you guys. The ones I have to make available is just the ESP32. This is a C6. This one has an RGB LED built onto the board, and it has a screen attached to it as well. I think it does have a few other features that make it a little bit more performant. Well, maybe not performant, but more feature heavy than the regular ESP32, in that you can program it to integrate with Google Home and I believe Apple HomeKit. I'm not sure, I never tested the Apple HomeKit part, but I have configured it to work with Google Home before, so like you can say, hey, and then you say, turn on the light, and then it will turn on the light, yeah? So that protocol that it uses to connect to Google Home, I believe is called Thread, or Matter, or maybe it's both Thread and Matter, or some combination of Thread and Matter. So that is something that we're going to probably talk a little bit about later on, because with what we have been covering, or what we will cover mostly in this class, is a RESTful API that uses HTTP. Soon get into that. That alone won't allow you to integrate with those, the home integration platforms like HomeKit and Google Home. So you need something compliant with Matter and Thread to be able to do that. So we'll get to that when we get to it. All right, so let me see now. I'm going to plug this into a battery. And the reason I'm plugging this into a battery is because I want it to be very clear that the behavior of this microcontroller has nothing to do with my computer. So let me just, let me share my screen. Hold this for me. Can't shock you. All right, and let me see now. Just to make sure it's working, first of all, let me talk a little bit about this application. So this application is called Postman. The reason I use Postman, I told you that when we make GET requests, you can simply make a GET request from your browser. Meaning if you just type in a URL in the URL bar in your browser, you're making a GET request to some server for a particular path or a particular resource. So anytime you type in google.com into your browser, it makes a GET request, it goes to Google, and it gets the front page, and it returns it to you in the response. By default, without any kind of code, that's the only kind of request that you can perform in the browser. It is not to say you can't do a put request or a post request and a delete request in the browser, but there's no simple way to do it. You have to write code like in JavaScript or whatever you're going to use to write your front end. And I don't really want to write any code to show you that. So what I'm going to do, instead, I'm going to be using a tool called Postman. Postman is a web tool that we use in testing and development. It doesn't have anything to do with the production or the end product of your application. The reason I'm bringing this up is because a lot of time, when I teach students about Postman, they will go into their final project and talk about how, oh, in order for my project to work, you need VS Code and you need Postman and something. You do not need VS Code and you don't need Postman. VS Code is just a text editor. It's the same thing as Notepad, except it has way more features. Same thing as Microsoft Word. It just have different features. So if you're building a system that's supposed to be some IoT-related thing, and you wrote your code in Microsoft Word, you're not going to tell the user that I need Microsoft Word, right? Because you just use that to write your code. Yeah? I'm hoping you don't use Microsoft Word to write your code. I'm hoping you use VS Code or something similar. But yeah, similar. Postman is just a testing tool. It is something that we use to simulate the request that a client would make. So if I write my code on the ESP32 to make a request to my server, I can tell Postman to do something similar. I can tell it that here is my server. This says mcledcontrollerapi.unrender.com, that's the server. And then the path I want to make a request to is /wool, right? And I talked about the body of the request. Oh, first of all, let me just make it clear, this is a post request. So I'm going to be sending some information to the server. And then this is the information I want to send. Let me see if I can make it bigger. That's clear, right? So this is my JSON body. It has 3 fields, R, G, B. Yeah? So what I'm going to be doing is I'm going to be making a post request to my server with these 3 values, R, G, and B. And if it works, it should influence the color that is showing on my microcontroller. So right now I have it set to B. So it's supposed to be blue, and I hope it works. Hold on, no, nothing's happening. Plug, oh wait, I wonder, actually didn't test it with the battery, the power bank. I tested it with my phone, like I plugged the microcontroller into my phone. Come again? Okay, there it is, blue. Okay, good, hold on. All right, so it's blue now. So let me change the color to red, 255. And I change it to red there, and it should take a, there you go, it's red now. All right, so that's just a proof of concept to say that it works. Okay, right, so let me explain. Before I move into that, before I answer your question, me using this tool Postman is just a proof of concept to say that if I make a request from some client that is a post request to this server at /wool with a JSON body of R, G, and B, then my other client, my microcontroller, should react. But this is just a tool. This is just a test to see if it will work. This is not the server, this is a client. It's a test client. Now I'm going to use my real client to make the request. And this is code that I wrote last night. So I can show you the code, but instead of showing you the code, I'm going to show you the actual thing. Hopefully it works. Oh no. All right, hold on. One moment. All right. So is which one again? This one. Oh, nothing yet. Just give me a second. So what I'm going to be showing, what I'm going to be showing is not Postman. I'm going to be showing you Minecraft. Effectively, what I'm going to do, I'm going to open the game, and I'm going to have some colored blocks on the ground, different color blocks. Whichever block I stand on, the LED is going to change color. Yeah? Yeah. So Minecraft in that case is my client, and it's making a request to a server, and this is also a client that is receiving the information. So it is not to say that I'm sending information directly from Minecraft to my microcontroller. I'm sending information from Minecraft to a server, and then my microcontroller is making a request to that same server. Why did it turn off? I think it's because, all right, I'm gonna like this power bank is the power bank. Let me see. Let's see, one sec. All right, so these are my blocks. Okay, it's red now, right? All right, let me just enable this. So wool track, I think, wait. Wool track, wait. Oh, Roll track. Okay. So it should be working now. So I can stand on white. It turned white, right? Now I'm going to stand on red. It should turn red in a second. It turned red, but it's a really faint red. Let me stand on blue or teal or cyan. I don't know. Let's stand on pink. See if it turns pink? It kind of pink. Stand on yellow. Is it very obvious? Yeah, it kind of yellow. Stand on purple. Is it purple? It purple. Stand on orange. And it's not really orange, but yeah. And then different color, yeah. So yeah. What I was able to do is, like I said, Minecraft is a game that allows for any kind of modification that you want, as long as you know to write Java. Yeah? What we're going to be looking at is how we can make requests in JavaScript, kind of. I may not be teaching you the JavaScript part, but I'll show you examples of how it can be done. JavaScript is just any language that you can use. It's just one of the languages that you can use to make requests. In Python, it requires you to know Java. So I got a HTTP client library, put it in a Java plugin file, and I wrote my code. I told it where my server is. I told it what the path to the application is, so /wool. And I told it that whenever a player stands on a particular block of wool, look at the color, and then send that color to the server. The server stores that and stops it. It don't do anything else. It just store it. And then now the ASP make a GET request saying, what color wool did the person stand on? And because somebody stood on some color and made a post request from Minecraft, and the API would have just pulled that previously stored data and send it back to the microcontroller. The microcontroller just apply it to the LED. Make sense? The server is in the cloud. So, let me explain. The server... Right. Well, that's not the reason, but kinda. Kinda. Let me see if I can show you. So Render is a cloud platform or a cloud service platform where you can write your code. I typically write my code in Python, and you can upload it to Render, and it will host it for you. The free version gives you limited hosting in that when you write your code and you serve it on Render, it will stay alive for maybe a few hours, and if nobody uses it, it spins down and it goes idle. It will come back up if somebody tries to use it, but it might take a few minutes maybe for it to come back up. So that's the free tier. The paid tier is just up and it stays up. Yeah? I think the free tier is something like $7 a month, or the paid tier rather is $7 a month. So it is something that we may use. If you want to put money into it, you can. If you want to use the free version, you can. All of these here are APIs that I wrote for different reasons. Anyone that you see that mark ECSE is probably an example that I did for class in the previous years. And some of them is just stuff I was just doing, become idle. Yeah? And I want to feel like most, if not all of these are written in Python, written in using the framework that I'm going to be showing you called FastAPI. So I think I would have mentioned this before. FastAPI is a framework, meaning it's a library that we use in Python. If we were to try to build an API or build a server application in Python, raw Python by itself, it would take a whole heap of manual configuration, and it would be very difficult, and our class would be much longer. So I'm going to be showing you how to use FastAPI to build those same functions that we can use to expose to the internet or expose to the network so that we can have a client connect to it. All right? When we write that code, when you're going to be making requests to your server or your API, let me see. How can I show this? Let me see. Real quick. All right. So consider this simple diagram. In this case, the client is Minecraft running somewhere, it don't matter where, and my microcontroller is another client somewhere. My server is also somewhere. So it is three completely separate components talking to each other, right? When you're writing your code, it is not to say that this will not be true. The thing is, the composition of your systems, the layout will be a lot closer. So you're going to write your code, and the code will be running on your laptop, and then you're going to be using Postman or whatever you use to make your requests, potentially also on your laptop, right? So it may look like it is a case where just because you wrote some code and you see a response and a request happening, it may look like it's local to your laptop, but it is entirely possible for you to write your code, expose it to MonaConnect, and somebody else on MonaConnect can make a request to your laptop, as long as you give them your IP address. No, it's fine. It's safe. It's safe. It not work. Mm-hmm. All right, we'll test it. You might be right, but we can test it still. Okay, so any questions? Let me close this. Render is a cloud service platform. So it is a bag of computers someplace in the world that you can write code and install your code onto. And that code will be accessible on the internet. Yeah? So you write your Python code. If your Python code is supposed to tell somebody hi, if them go on the website, you go on the website and it's a hi Philip. As long as you put your code that handles that logic on the cloud service, whether it be Render or AWS or what else you have? Render, AWS, Azure, Vercel, Netlify, and a bag of others. You choose whichever one you want. Because they allow your code to be exposed to the rest of the internet, anybody, as long as you allow it, can make a request to that server and access your code. All right? Mm-hmm. All right, so let's get into it now. First thing, we need to create a project for today's code. Let me see, where am I? Where's my ECSE folder? Are we in week 3? You guys watched the video I sent, right? In the group chat? I posted a link to my YouTube so that you can see all the stuff that I posted so far. One of the videos I posted, it was a video that you could have pulled up easy on your phone. I made it so that it is vertical. Yeah, it was something that we needed for GitHub related information. Sometimes I see people make mistake, and when they're trying to upload to their GitHub, then again, I can't blame you because I didn't teach it explicitly. When you're trying to upload something to your GitHub, if you already have code, it will ask you for a message at the top. The message is not optional. You have to put a message every time you upload. Yes, it's a note to yourself to remember what changes you made. And you may think that, yeah, I'll just remember. No, you won't. You will not remember. When you're writing code, you write code on Monday, and on Friday, you upload your code. Monday morning you come, you don't remember how you were smart enough to write this code. You are wondering, how was Past Philip this smart? Me can't understand the code, yeah? So how Past Philip understand this code, right? So you need to write notes to yourself. It can be a short note, it can be a long note. It don't matter, as long as you put some message. You can just put the word changes if you want. Don't do that. Make it meaningful, make it concise, and just make it, like I said, meaningful and concise, yeah. So, I created a new folder. It is an empty folder. I call it, as a matter of fact, I don't want to call it week 3. Hold on. Week 3 too general. So in week 3, I'm going to create another folder, and I'm going to call it lecture 1. It's called lecture 1. Now I can open my VS Code. Okay, so I'm going to create an app.py. And this is where we're going to be writing our code. But before we write any code, last week I would have talked about something called a virtual environment. Very important. We all have Python installed on our computers. And the Python that we have installed on our computers is our particular version. You can install libraries on your computer using that version of Python, and those libraries have their particular versions. But we don't want to rely on the system-wide installation of Python. We don't want to rely on the system-wide installation of the libraries. We want each project to be self-contained, so that if it is a case where you want to hand over your project onto somebody else, they can open the project, see a list of all the libraries that you used, and just press one button and install everything into the project folder. You don't want your code to interrupt somebody else's environment or somebody else's libraries. Yeah? Because it might be a case where I'm writing my code and I'm using FastAPI version 1.0.1. Because in that version, it allows me to do some things that only I understand. When I get your code and I install version FastAPI 2.3.7, it's going to remove the functionality that I was relying on for my code. I don't want that. I want to make sure that all the libraries that I install are local to the project I'm working on, so that it doesn't affect any of the other projects. So here's what I'm going to do. I'm going to open my terminal, and I'm going to use terminal, new terminal, or you can press Control tilde if you want. And I'm going to say, yes, Python -m venv venv. And I'll explain what this is. So I'm telling Python to use a module, the -m is module, I'm telling Python to use a module called venv to create a folder called venv. So the first one is the module name, the second one is what me want to call the folder. I like to call it venv because it's easier. The module name venv just created a folder called venv. If you want, you can call it something else. I don't know if it's going to cause problem for me when I'm marking. I don't think so. I don't think so. I think you can call it anything you want. But just treat it as me telling you, just call it venv. It's easier. Yeah? There's some tutorials online that will tell you to call it .venv. I don't know why. I just call mine venv. So I'm going to press enter. And after a few seconds, after I give you back your prompt, you should notice that there's a venv folder in your workspace. Give it a sec. All right, so now it's finished. So with the venv created, we need to now activate it so that the terminal knows that anytime we type the word Python, it's not supposed to use my computer Python. It's supposed to use a venv Python. So in order to activate it on Windows, we're going to say venv /scripts with a capital S /activate. And you press enter, and you should see, well, it's green on my computer. I don't know if it's going green on yours, but you're going to see this venv in front of your prompt. As long as we see that venv in front of the prompt, then it is activated. I think an easier way to do it, I believe, well, I'll soon get to that. So do that. Let me know if you have any problems. Say again. You know what that is into a meter bridging? You just have venv. I have Python -m venv. You need all of that bridging. All of that. If it matters to anybody, I did post some PDF documentation on VLE with all this information in it. So if you need something to read, you can read it. If you want, you can go back to the video and listen back to it. But yeah, it would have been covered from last week. Yeah. So you created the virtual environment. After you create the virtual environment with this command, we activate our virtual environment. Now that we have our virtual environment activated, we can now install some libraries. Let us install the FastAPI library. So I'm going to say pip install, oops. It is a Python package manager. I don't know what pip stands for, but it's a Python package manager. Install. It is already installed. As long as you have the venv, the pip should already be accessible. As long as the venv is enabled or activated rather. So you can say pip install, and I'm going to say FastAPI. And again press enter. Ignore the message that comes up in VS Code. So it should download and install FastAPI in your virtual environment folder. By the way, I think I've seen this in the past where people will mistakenly write their code inside the venv folder. That is incorrect. You are not supposed to manually modify your virtual environment. You're supposed to create the virtual environment and write your code outside or beside it. So make sure it's closed up, and then you write your code out here so. The only modifications to be made to the virtual environment should come from the terminal when you type your pip install them something. Yeah? Yes? Question? It should say, yes, it should say venv right here when the virtual environment is activated. Yeah? And then you're going to say pip install FastAPI. Just like that. pip install FastAPI. And you press enter and it should download and install FastAPI to your virtual environment. And we can check to see if it's installed. The way we check to see if it is installed is we go pip freeze. And we do this while the virtual environment is activated. You press enter, and among other things, you're going to see FastAPI. The reason we have more than just FastAPI is because in order for FastAPI to work, it is dependent on other libraries. So when you manually install FastAPI, FastAPI will install other things so that it can work. So these are the other things that it needs to work. We looked at Pydantic last week. Pydantic is a dependency of FastAPI. Yes, so it will automatically install Pydantic for you. Yeah? Mm-hmm.
So which way does it?
Pip freeze. Type pip freeze, pip space freeze, and press enter. What's Starlet? Come again? What's Starlet? I think Starlet is dependent. Sorry, Pydantic is dependent on Starlet. So in order for Pydantic to work, Starlet must be installed. I don't know exactly the hierarchy. Some things here are dependent on other things. FastAPI is dependent on Pydantic. I guess Pydantic is dependent on Pydantic core. Pydantic is dependent on Starlet. I don't know what everything else is. I have no idea what everything else is. Yeah?
So what is freeze? What do you mean by freeze?
Freeze shows you the list of libraries that you have installed.
Oh, okay.
Yeah.
What the odd name?
Yeah. Okay. Another library that we need to install in order to make it so, okay. We install FastAPI so that when we write our code, it allows Python to understand the API related code that we're writing. So that just determines the logic of how the API should work. We need to install another library to take that code and expose it to whatever network we're on so that other people can interact with it, so that other requests can come in. That library is called uvicorn. So I'm going to say pip install uvicorn. U-V-I-C-O-R-N. And uvicorn is not the only library that allows us to perform this action. I was looking it up and I saw that there were some others like, hold on, let me just look it up. It's funny it said Pegasus because I'm pretty sure uvicorn, U-V-I-C-O-R-N, uvicorn, yeah. Let me see. uvicorn PyP. All right, so there are a bunch of others. The first one I noticed is Daphne. Apparently Daphne is another library they can use that does the same thing what uvicorn do. I don't know why it named Daphne. If anything, it might be similar to why MySQL is called MySQL. You guys know why MySQL is called MySQL?
No.
So the language, you're familiar with SQL, the language. Yeah. SQL stands for Sequential Query Language or something so. My is the daughter of the guy that invented MySQL. In daughter named My. That's why he made another database application called MariaDB. Maria is My's sister. No joke. Yeah? So maybe Daphne was the name of the daughter of the person that created it. Maybe Daphne created Daphne. I don't know. But apart from Daphne, we have Hypercorn, we have Mangum. Almost said Magnum. Yes, yeah, Mangum. All these applications, they effectively do the same thing as uvicorn. So you can choose whichever one you want to use. After you write your FastAPI code, Mangum or Hypercorn or Daphne or uvicorn will just take your code and make it available to the network that it sits on so that other people can make requests as long as they're on the same network. Good? Yes? Okay. All right, so we're going to be installing uvicorn. So I say pip install uvicorn. Let me make sure it's installed so I can say pip freeze again. Okay, let's find out. Pip meaning. Wait, it's going to tell me a general definition. Pip Python meaning. Pip installs package. That doesn't. Okay. So pip stands for pip installs packages. Now you're going to be asking me, what does pip stand for? So we have this weird funny thing in computing called recursion or recursive naming, where something that stands for something will have its own name in it, what it stands for. Like there's this application on Linux called Wine, where it's supposed to be able to emulate Windows applications on Linux. Wine stands for Wine is not an emulator. And then you have this other thing called PHP, which is a programming language. It stands for PHP Hypertext Preprocessor. It calls on itself. I don't know why. Yeah? Nerds are weird. All right. So apparently pip stands for pip installs packages. It is a Python package manager or library manager, whatever you want to call it. So yeah, I just did another pip freeze a while ago. And you should see Uvicorn down here so now. I'm not sure if anything else got installed. Maybe H11. I don't remember if I saw H11 before. But whatever, Uvicorn is now installed. Yeah? So, very important. Very, very important. Anytime you install a library, you need to make sure that you have a file in your project that keeps track of all the libraries and their versions. So that if you tell anybody else that they must download your work and install the libraries that you use so that it works the same way on my computer as it works on yours, we're going to create a file that keeps track of all those libraries and those versions. And we're going to be doing that with same pip freeze, but we're going to add another thing to the command. We're going to say pip freeze, and we're going to say greater than, and we're going to name the file. Conventionally, we name that file requirements.txt. So take a look at my command. Pip freeze space greater than. Come again? It's going to create a text file called, did I spell requirements correctly? I really hope that you guys all spell requirements correctly, because when I'm marking your work, I am not going to guess which libraries you have installed. I'm going to hopefully install all the same libraries that you use during your work. So I'm going to use a command that will just look in your requirements.txt and just install everything exactly as I see it. And if it is not called requirements.txt, and I don't know how your thing spell or how your thing work, I'm going to have a problem, and you're going to make that marking difficult for me. So I'm going to press enter. And it will create a file called requirements.txt. Did I spell it correctly? Requirements, yes. And when I open my requirements.txt, we will have seen all of my files that I just installed. And it look color because VS Code knows what a requirements.txt file is supposed to be. So you can color code everything. Yours may not be green and purple, but mine green and purple. Tell me if it worked for you. If it didn't work, let me know. Why in here so hot? Cold front gun, sure. Okay, did you get the requirements to be created? Yes? All right. All right, so let me see now. I think that's all the setup that we need. Let me tell you, when we're creating a new project, we have to do this setup every time. Yeah? Every time we're creating a new project, we do all of these steps at the beginning, and then you start writing your code. So, I think yes, it should be. I don't remember if I put this in the document, but I'll edit it if I need to. So, first you start off by creating a virtual environment. After you create a virtual environment, you activate your virtual environment. After you activate your virtual environment, you install your packages or your libraries. After you install your libraries or your packages, you create your requirements.txt, and then I feel like you're good to start writing code. Yeah? All right.
What is this again? ESP32?
That's an ESP32C6. It's the WaveShare branded one. All right, so now, after all that long drawn-out setup, we can start writing code. So let's start off by writing some Python code that allows us to see some simple text in our browser. So first thing we need to do, we installed FastAPI, we need to import FastAPI. So I'm going to say from FastAPI import FastAPI. And you have to write it just like this. VS Code is probably going to complain because VS Code doesn't know that FastAPI is installed.
So we can write this in app one?
In the app.py. Oh no, this one is here. Wait, why is that? Oh, this one is telling me that there is one issue inside my code. That's what that one means. I'm going to tell you how to fix that issue. You'll have the same issue as me, more than likely. Come again? Oh, that means you already started working in a Git repository, but you shouldn't be. You shouldn't be working in a Git repository. You should be working in a brand new file that have nothing to do with Git. is the folder that it is in inside of a Git repository?
That's the question now. Yeah, I think so.
Yeah, you need to not do that. You can't put a Git repository inside of a Git repository. You need to. Yeah, they're the same, but they're different. They're entirely different. They should not be related.
So what's the issue you're having?
He's seeing you here, which is Git is telling you that this file is brand new and it don't know about it. It's asking if you want to make Git know about it. But Git not supposed to know, say it exists in the first place, because this is not a Git repository. It should not be a Git repository. You need to make a brand new folder somewhere else. All right, I'll show you how to fix it later. Can ignore it for now.
So it's supposed to be nothing. It's supposed to say nothing.
Well, you're supposed to the one, and it's supposed to have FastAPI yellow underline. Let's fix that. VS Code does not know that FastAPI is a library that exists. So we will tell it where it exists. We'll tell it that we have a virtual environment, and it's installed in the virtual environment. So we can come down here, we can click on this. Yours might say 314 Microsoft Store. Just click on that, and then tell VS Code that we're supposed to be using the virtual environment. My virtual environment is Python 3.12 because I installed Python a long time ago. But yours might say 3.14, kind of brand new. The yellow underscore, the yellow underline should go away now. Okay. So now, in addition to it being calm and not badgering you about, what is FastAPI, it should also now give you documentation while you type your code. It should autocomplete. It should also give you suggestions. Without you telling VS Code where FastAPI is, it wouldn't be able to do all that stuff. All right. From FastAPI, import FastAPI. So now that we have FastAPI imported, we need to, initialize the FastAPI object in our code. I'm going to call it app. So I'm going to say app equal to FastAPI. Open and close my parentheses. Write this for me. We will be using this variable called app. Do I need to zoom in? Let me close this up. I don't think I need this anymore, so I'm just going to zoom in. Don't need this right now. So we're going to be using this variable to control a few things in our code. So I say app equal to FastAPI. If I write it just like this. All right, so now let us write a function that we will use to handle an incoming GET request. So I'm going to say at app dot, and I'm going to say, is it get? So at app dot get, and open and close your brackets. At app dot get. And I'm going to write a path. So I'm going to start it with the slash, and I'm just going to say, let's say slash home, or no, let's call it slash greetings. All right, and I press enter. So at app dot get. And in my double quotes, slash greetings. I'll soon explain what the slash greetings mean.
Okay. New line.
New line now, we're going to write a function. Same way we've been writing functions in Python from before. We have def. And you can call it whatever you want. I'll call mine greeting, or greetings as well. And in this case, greetings will not take any input. So I'm just going to leave my parentheses empty. And then I'm going to say return. And let's just say hello. Two-line function with the decorator on top. So let me explain what this do. Actually, before I explain what it do, let me just show you how it works first, and then explain what it do. So this is my server. This is my entire API. I am now going to tell Python to take this code and expose it to the network. At the moment, I'm on my hotspot, so you're probably not going to be able to access it on mine. But if you write yours, you're saying you won't be able to. We can test and see if it's true. But it should be accessible to the network. So I'm going to say uvicorn. Yes. Oh, uvicorn. That is the application. That's the web server. It serves your code. It's the web server. So uvicorn serves your code to make it accessible to other clients. So I'm going to say uvicorn. Come again? What we're writing is our API, or our server-side application. Server-side application. It's the application that runs on the server. All right, sure. Yeah. Okay, and then Uvicorn hosts it, or it serves it. It doesn't host it, it serves it. All right, so I'm going to say Uvicorn app colon app. I believe this will only work if your file is called app.py. One of them two apps there is the name of the file, and I don't remember what the other app is. I think it might be this. So I think we say app colon app because I believe this is called app and also our file is called app. Just do it the way I do it. It less confusion. Yeah.
Which one I file?
Me no know. I think the first one is the file.
File then folder.
Well, file then something.
Function.
I think so. Huh? All right. So I'm gonna run this now. And when I run this, I'm gonna get some information. And the information is going to tell me, firstly, that I started a process. I started the server process. So my server is running. Uvicorn is serving my code. It's waiting for application startup. The application startup because the code's simple. And now, if you want to make a request to it, you make a request at this IP address and this port.
Me get error, sir.
You get an error.
We get error loading ASGI app attribute app not found in module app.
One sec. Module app. Oh, save your code. I'll run it again. Press up and then enter. Virgin.
What's that?
Yeah. All right. So, what's that? 127.0.0.1 colon 8000, right?
Yeah.
All right. So let me explain this. Do I need to explain this? Are you guys familiar with this?
We did talk about it, but you can go through it again.
All right, no problem. Dr. Rakinapa, Kopa?
Oh.
No?
No.
Do you have a question? You get an error. Let me take a look at your error. All right, so okay. Uvicorn. Oh, you need to activate your. Oh, you have a virtual environment installed. You need to install the virtual environment. Python. No, this. Oops. How do I? Yeah. So this first. Create a virtual environment. After that done. Give it a second. Come and finish. Right, so we know what IP addresses are, right? All right, I'll come in. Yes, question?
Yeah, so my thing is the line right here, and I just wanted to know what the line is.
Oh, all right, give me a second. Let me get through this explanation first and I'll come to you. All right, so an IP address is like your actual address, your home address, right? It tells you where on the internet you live or where this application lives. All right. So my application at the moment lives at 127.0.0.1. Your application might live at the same place. The reason why your application live at the same place mine live at is because 127.0.0.1 is just the computer's way of saying home or here. It is not the actual IP address on the internet. It is its IP address on the computer. And since your laptop is the computer, it is the home, it is telling you that your application is running here on home. Yeah? So 127.0.0.1 is how the computer refers to itself. The port now, 8000. All right. If you live in an apartment building, you have more than one homes inside the building. The IP address is the address of the building, but the port number is which apartment you live in. So I live at 123 Bob Marley Road, Unit 1. Unit 1 is my port. Yeah, 8000 is my port. So if somebody needs to send you mail, they're not going to send it to 123 Bob Marley, what I say a while ago, Bob Marley Road, whatever I say a while ago. Because then who's going to get the mail? The whole building going to get the mail. We're not going to know who unless you put some identification on the mail. But if you want to go through that, just put which apartment number is supposed to get it. In this case, my application is running on my computer at port 8000. That means I can have more than one different applications running, more than one servers, or more than one APIs running on my computer, as long as the port is different. The IP address can stay the same, but the port must be different. And the port can be different by one. It can be 8001, it can be 7999, it can be 1024, it can be 65535. I believe the ports that are available to you as a user is between 1024 and 65535. 65, I think so. Something like that. You can test if you want. And I can show you how to change this if you want. But for now, we'll leave it at 8000. I can show you how to change it later.
But the question,
Yes.
everybody live in the same apartment.
Because each one of our laptops is an apartment building. Is an individual building.
So if it's that case, you're one apartment, we have 1 to 10. Me, I 1 to 10 here, so I'm 1 to 10 over there. So
Come again.
everything is, this is the home, the apartment. Everyone have the same 1 to 10 unit on the laptop. So, say for example, this apartment can have 1 and that have 1.
Yes. Because this computer though is more that computer. So it's going to refer to itself as home. And if it says home, it's not talking about that, it's talking about itself.
So then you're saying, that's why you say it's different from on the internet because we could have the same.
Right, right. So it's like everybody here refers to themselves as me. I call myself me, you call yourself me, you call yourself me. But when I say me, I'm not talking about you, I'm talking about me. So that's why the computer can call itself 127001. And everybody computer can call itself 127001. Because they're referring to themselves. All right? All right. If we were to all expose our code to MonaConnect, if it was possible, we'd all have to have different ports. Because we can't all be, MonaConnect would allow us to connect to the internet. So we would all have the same internet IP address. We'd all be sharing the same IP address because we're all on the same internet. And we're all connected to the same access point. But we'd all need to have different apartment numbers or port numbers. Yeah? Okay. Let's see what this does. Okay, open my browser. Oh, you got 404? All right, actually, let me show you why you got 404. All right, so I got 404 as well. And yours may not look the same as mine because I have an extension that takes my JSON and make it look pretty. It's called Pretty Print. You can install it if you want. Right?
Pretty print?
Yeah, Pretty Print. So it tells me detail not found. And it's telling me detail not found because it's 404. I'm making a request to a server for a particular resource that don't exist. The resource I'm looking for is called slash. But let's look at our code. We don't have any function that is supposed to be able to serve a request to slash. We have slash greetings, but we're not asking for slash greetings. We're asking for slash. So let's go back into our browser and put slash greetings. And you should get hello.
So, alright, we can also try to get that error.
All right, let me see what I'm doing. So it's there. So now I need to activate it by saying venv. Oh, it tells me.
You get 404 you get?
And then we say pip install uvicorn and FastAPI. You don't want to complete that? Then FastAPI. The order of the operations matters. So you create a virtual environment, then you activate it, then you install some of them. Did you already freeze? Oh, you already freeze. Oh, that means you install these on the system Python. We can uninstall them, it's fine. Yeah. So let me refreeze. Let me delete this. And convention is, it should be called requirements with an S. I hope everybody else got that. Probably not. Requirements. All right, so that's done. So I'm going to say pip freeze requirements. It should populate this file. All right. So, and then last thing is we're going to this. I will need to tell VS Code. Oh, you already did that. Good. So now it should work. You should be able to say uvicorn app colon app. It looks like it's going to work. It should work. All right, cool. It'll work. I'll come in. Give me a sec. I need to go to Tarek first. I'll be right back.
So what happened? So I fixed the red lines. However,
You get yellow line now? Yeah. So a couple things. So you have your. Let me see something. Did you write this?
Yeah, because it never, I created it in the Venvi index, however, it never came in that, so I just made that
Cut this.
reply.
Say that we are not supposed to write any code inside the virtual environment, so I'm going to delete this. Virtual environment should not be edited by us. Paste that there. Save it. I'm going to rename your code to app.py. Alright. Next, I'm going. Oh, but it's inside lecture.
Yeah, so that's why I was.
Oh, we don't need a folder called lecture.
But you
Oh, yeah,
created
I
the-
get what you're saying. Alright, here what I'm going to do. I'm going to delete this. And I'm going to open VS Code to the lecture folder instead. VS Code. Let me see. New open folder.
So lectures on the desktop.
Okay. So this, there. So now I have it open there. Good. So now this is at the root. Now you can create your virtual environment. This. So go through the steps and create your virtual environment. Just install your stuff. You have an issue?
Yes, sir, I just stuck there, sir.
It's stuck right there.
Yeah, after I
Yeah.
got the link.
Yeah, man.
Yeah.
Oh, it didn't open anything?
Yeah, it opened.
Oh,
Yeah.
well, you're good then.
But, sir, I can't.
All right, let me explain. So, the issue that your classmate is facing is that after them run them application, it's stuck. It's just here. I can't type nothing. It happened to me, yeah, it's supposed to. So, the reason why that happened is because when we run our code, it is not something that is execute and stop. It's executed and it stays up. And we're able to access the API as long as the API is being served. Yeah? So Uvicorn brought up our application and continuously serves it all the time. It's just always serving. It is waiting for incoming requests. If we kill the server with a Control C and I try to refresh my server, it should not work. It doesn't work because the server is no longer accessible. I killed the process.
So where's the Control C to quit?
Control C to kill it, yeah, to quit it. Apologies for the harsh language, that's just what they call it. You kill the server, you kill the process. Yeah? Yeah. There's a lot worse nomenclature. Put this, so in your code, you said that you are writing a function to serve /greetings. So at the end of your URL, put /greetings. Assuming you put the same thing as me. All right. Mine doesn't show the IP? Mine don't show it? So, all right, let me put this on the side. Let me show you what happens. I'm going to put this here and put that there. Watch what happens. Wait, hold on. Look at what happens when I refresh my browser. Another one comes up. I'm going to refresh the browser again. Another one comes up. Refresh the browser again. Let me put greeting instead of greetings. Enter, 404. Yeah. So these are my logs. Yeah. This is my transaction history. It is showing me what requests somebody was trying to make to my application. So I made 3 GET requests to the same place, and it served it with a 200 OK, because that means good. But then I put /greeting, and it's telling me somebody tried to access /greeting, not no name so it's a 404 not found. Yeah? Make sense?
Yeah, asking about how I'm going to display the 127 beside the error, but not 404 not found.
See that? It's just in a different line, because everything is squeezed up here. They're all the same.
Everything to the left is the laptop address.
Yes, because it's telling us who is making the request.
But on the server, the 5
This is who is making the, this is also who is making the request. So the server lives at port 8000, but my browser lives somewhere else in the apartment. So you can't send something to your own home. Well, you can, but you know, this can't. The server is one apartment, the client is another apartment. The client lives here, in the same building, but in a different unit. The server lives in unit 8000 and you live at somewhere else. Your number here might be different from mine, I believe. Yeah, that's fine. Every request is handled individually. Mine doesn't change. This. Oh, I don't know why. Sometimes it changes, sometimes it don't change. Every request is handled independently though.
So it's not dependent on the unicorn.
Not really. Unicorn is not what caused that.
So this number, 590, is another number that laptop was served.
Kinda, yes. It's not serving, it's a client. Both servers and APIs and clients have ports. Yeah? So you send information from one port to another port. All right? Any other questions? We're good so far?
It's a hit public IC.
Does mine? Oh, okay. Yeah. So it's telling you that the favicon is 404ing. I'll tell you what a favicon is. See this icon right here, sir? And this icon? And that one, and that one, and that one. Ours don't have none. This is the default icon if you don't have none. So it is something that the server, this icon comes from the server. It is a picture in your code that the browser will automatically ask for so that it can put it in the tab. And if you don't have one, you're going 404 because it's asking for the favicon and you don't have one. I think the file is called favicon.ico. So if you had a picture in your code called favicon.ico and you wrote some code to make it so that if the person asks for it, you give them, it will put it right here. So, yeah? But because you don't have one, by default, it's a request that the browser makes to put it up in the tab. And because you don't have one, it's 404. Yeah? Okay. So we have greetings and all you do is say hello. But let's make it so that, yeah, pretty print it. Make it, oh, this don't pretty print. All right. Let us make it so that instead of just saying hello, it says hello to whoever puts their name in the browser. So I'm going to be using what is known as a, what name again? A URL, what name again? Hold on. URL parameter, assign name? That's a query parameter. I don't remember what name. Page. All right. We're just going to call it a URL parameter because I don't remember what name. So I'm going to create a placeholder for some information that can be filled in by the user. But I don't want to put in the folder that already exists. I'm going to put in a different, sorry, not folder, function. I'm going to put in a different function. So I'm going to make another @app.get. And I'm going to say, hello, again call it slash hello. Oh, hold on, let's call it greet person. Greet, you call it anything you want. Call it greet person. I'm going to put another slash, open and close my curly braces, and I'm going to say name. All right, create another function. Def, greet underscore person. This function now takes some input. The input that it takes is going to be whatever the person said their name is. So this is the placeholder where the person will put their name. And when I say where they put their name, I don't mean you must put your name right here. So the code must be generic and it must allow for anybody to write anything they want. So you will put in curly brackets just the variable called name. And then in your parentheses for the function, you will also put name. And now you're going to return hello plus name. Oops, name. Yes? You can use f-string. Well, you can't use f-string. All right, notice. Wait, can you use f-string? Maybe you can. Put an F right here, so it works. Holy moly. You never know, so you could have f-string outside a print. Not bad. All right. So save your code. Go back in your browser and go to slash, whatever you call it. I call mine greet-person slash name. So put slash greet-person slash and put your name or put a word, put anything. And tell me if it works.
So we should run it? Okay.
Yeah. That's an excellent question. And I'm kind of upset that you asked me because I wanted some people to get confused. So here's what I would expect you to do. I didn't kill my server. I just wrote my code and I save it. So I'm going to go now to greet-person slash Philip and it'll go 404. But how are you going 404 when the code is right here? I don't think I made any mistake in what I typed. The reason is when you run your server, when you make changes, it does not reflect. It just runs what you wrote last and ran last. So you have to kill it and start it back. So I have to go here, Control C, start it back. And now it should reflect. Hello, Philip. Unicorn space app:app. But here's my thing, right? I think I'd be a terrible person if I didn't give you a shortcut on how to get around that, make a change, kill the server, start by the server, run your code. So I'm going to show you how to get around that. Unicorn has a built-in feature where it listens for every time you make a change to your code. And when you make a change to your code, it automatically reloads itself by doing this, --reload. So unicorn space app:app space --reload. When you put the --reload, it will listen for every time you make a change to the code, and when you make a change, it will restart the app with that change. Come again? SSE, what is that? Server-side event? Kinda, yeah, similar. Or like an interrupt, yeah.
So what's on the where it says attempt was made to access socket in a way forbidden by its access permission.
Good Lord, what? Oh, it is entirely possible that you already have Unicorn running over there in a different terminal. You absolutely do. So you have to kill that. For some reason, you have two terminals. So use the
Control C?
Control C. And if you want to close this terminal, or if you want to use it back,
So what is okay,
trash can.
so
Yeah, let's kill it.
kill
Yeah, trash can. Yeah. And then right back.
And
the
let that
command.
is that?
Yeah, that one's fine. And press up on the keyboard. Enter. There you go.
Right.
So now every time you make a change to your code, let's say for instance, I want to be grammatically correct. I want to put a comma right here, so because you need a comma, I'm going to save it and it automatically reload my code. You're getting an error. Unicorn app, :app. You're not in your virtual environment.
Come out there.
Me no know. So it's a VENV. Scripts. Oops. Scripts. Activate. Enter. And now it should work.
Well, as if I kill a terminal, they will come out there virtual.
Yeah.
They do.
All right. So reload. Put reload on the Unicorn. Make a change to your code. Save it, and it should reload. How you pull in the name of the person? So you pull in the name of the person, just like how we see it here. We will have /greet-person/name. In your browser URL, after /greet-person, put slash and then put your name. Yeah. Whatever is written here is how you access this function.
So we add greet dash.
Name, yeah, we can call it whatever you want. I just call mine greet-person.
I don't have to say so right dash greet, right? Greet dash
Write it.
person in my name.
In the code, don't put your name. In the browser, put your name. Yeah.
Hello.
Yes.
So I realize that I'm working in PowerShell and not Unicorn. Why?
No man, that's fine. So you're in PowerShell and you should be able to run the Unicorn. Did you type it before? You did not type it before. Unicorn app:app. Let's put a reload on it. Take out the space right there, so.
Space.
Yeah, the space before the G. Move the cursor, right there, so. That space before the G, it's supposed to be slash. Move the cursor. Right there, the orange line.
Oh.
Yeah, take out that space. Save it, Control S. All right, open your browser and go to greet person / name. It should work. Okay, yeah, question. Come again?
Not found.
Not found. Greet person. Oh, you need to save. Click here, so. And save. Control S. Always save your code. When you reload, go again. Go back to your browser and refresh. There you go. Remember to save your code. All right. With that in mind, let me ask you now to write a function for me. I want you to write a get request handler that takes 2 URL parameters. This is a URL parameter. Mine currently only takes 1. I want yours to take 2. They're separated by a slash. So if you want to take 2, you can put name, / and then something else, as long as in curly brackets. Yours is going to take 2. Get those 2 URL parameters, add them together, and return the sum. So they should be numbers.
So you want me to write something?
So make another get request handler. Do not modify the function. Create a new one. So it's a get request. So because it's a get request, we're going to write at app.get. And you're going to give your path a name. You can call it add now if you want, because it's a string. Python don't business about that, so you can call it /add or /calc or /adder. Yes. So you're just going to take 2 different numbers.
You can say everybody so
Each URL parameter should be separated by
someone
in a slash.
and then /number.
And when I say separated by a slash, I mean each one should be in its own curly brackets.
Yes.
Okay,
and
good.
slash.
Good.
And then
Yeah, so this not working out. So
You need to put the beginning, bro.
the beginning.
So, where is the server? The server is 127.0.0.1. And it's running on port 8000. Port 8000. Let's run that. It should 404. And then you wrote what? Greet person
Yeah.
dash person / me. Hello, me. Can somebody tell me what to write? Put the word summation right here, so. Oh, put a slash, you said? Wait, here? Here, yeah. Num 1. Num 2. Come again? I need to put a slash up here? Oh, okay. All right, what next? Define adder. Num 1. Num 2. Do it come again? The F is, it allows you to put your variables in a string. Wait, name? F string? I don't know. F string. The sum. Oh, okay, sum is, and then I put, oh, comma? Wait, where? Here? Inside? Okay. That's it? All right. Let's see. What is the name? Summation. So I'm going to take out this and put summation / 6 and 7 for no particular reason. It's a 67, but why? So I mean, it's mostly correct. You're almost right. It did in fact get the 6 and it got the 7. And it put it in the return statement, but it never add them. This is not FastAPI, this is Python now. Why it never add them? Instead it joined them. Come again?
I think it's concatenating.
It is concatenating. Yes, by default, when you have your values up here in the URL, it does not know that it's supposed to be considering them as numbers. They look like numbers, but Python don't know that they're numbers. As far as I know, Python does count them as characters. So we need to tell Python specifically that num1 and num2 are numbers. And we can do that. You can do it more than one way. You can cast them as integers in your code here. But can I get to? We want it to make it so that as soon as they are accepted into the function, they are considered integers.
We have to do the same thing like we did with the dictionaries and double quote them.
Oh no, we don't need to double quote them. So at the moment they are numbers and we need them to be considered numbers. So I think it's either right here, so is right here so? Int, that's so? That not seem right. I think is here so, colon int. Colon int. I believe that to be the case. Come again? That's in C or Java. One moment. That's my other job. Right. So no, that's not a okay. Anyway, yeah. So I would have told the function whatever numbers come in, num1, it is supposed to be interpreted as an int, and it's supposed to be interpreted as an int. I'm thinking about it now, and that means if I put a decimal, it's probably going to crash. Is it going to crash, or is it going to cut off the decimal? Let's test it out. So I'm going to save, and it will automatically reload my server. And then, whoops, my browser, I'm going to refresh the page, I'm not going to make any change, and now it says 13. Go back to my code.
And all you did was to put
Int next to the variable.
next to the variable.
The variable specifically in the definition line. Python really likes English? Why? Because it's a string? Oh, I mean, you can write everything. Oh, because we put int after num1. I get you. Python does enough. We don't know. Python different. So it is similar to what you're saying. Actually, it's not similar. It's exactly correct. We are defining the type. So we're specifying in C and in Java, you'd put the type before the variable name, but in Python, it wants it after. We don't know why. That's what them stay.
And yes, it does. So go up to the
Browser. Let's go back to the code. All right, let me explain that in a way that you can write on an exam paper. UVcorn don't send anything anywhere. UVcorn just makes your code available. So you make a change to your code. When you save it, UVcorn knows that you made a change to your code, so it kills the previous server and starts a new server with the new changes. Now in your browser, you're using your browser to make a GET request. And that GET request is handled firstly by UVcorn. So UVcorn get it and hand it over to FastAPI. FastAPI go through the list of functions that you wrote and see which one in your request match this thing right here. So if in your GET request it says /summation, FastAPI going to say, all right, this function needs to handle it. If it was /greetings, the function up there must handle it. Yeah? They're all GET requests, but they all have different paths. So the path is what determines which function executes your code. Yeah? So the first thing that happens is it checks the IP address. Because you're making a request a particular IP address on a particular port, UVcorn get it. When UVcorn get it, It hands it over to FastAPI. FastAPI look in the request and say, all right, who's supposed to get this message? It's supposed to go to the person that is making a GET request first, but we have 3 GET request handlers. Which one? We check to see which one of the paths it match. If it's summation, this one. If it's greet person, or greet dash person, that one. If it's greetings, that one. Yeah? And depending on which function get it, it just performs the logic as defined by the function.
So because we now control front end,
Yeah, you're sending GET requests.
So we can manage the front end.
You can, but you need code. So, no. Entirely different code. Something that I may show you how to do later. Yeah? What's that? F12. Or FN F12, one of them. Developer tools, yeah. All right, so we're good so far?
No, sir.
No, we're not good? How can I assist?
That's what I have to.
All right, no problem. Does that mean I need to pause or I can move on to my next thing? Let me see. Let me look in my notes and see what else I wanted to do. The temporary changes, yeah. I don't think so. My iPad updated. Give me a second. All right. Let me see. This upcharge. Upcharge.
Alright, so it was in that made 404 error, sir. I don't know why.
Let's see why. So this says slash sum. Oh, you need a slash before the word sum.
Before it?
The slash before it. Notes. For this? All right, so we did that, we did that, we did that. Oh, so we did that already. Oh, okay, we can do this. Cool. All right. Let's introduce JSON or JSON, J-S-O-N. All along, we've been creating our functions to return plain text, just some strings. But APIs and clients and servers, they don't talk like this. They talk in a bunch of different ways, one of which is JSON. So we have a client that is making a request. More than likely, that request is going to be expected to result in a response that is formatted in the JSON format. So we need to take this and convert it to JSON. So instead of saying return all of this stuff, let's make it more machine friendly or JSON friendly and say return. I'm going to open and close some curly braces. I'm going to put a name, I'll call it sum, and a key. All right, I don't want to do the math right here, so I'm going to write the math somewhere else. So I'm going to say answer equal num1 plus num2. Then I'm going to say sum equal answer. Yeah. You can put num1 plus num2 right here, so but that's kind of junky, I don't like it. So do the math somewhere else and then use the variable in your return JSON, and then just return, refresh the page, and you should get back a JSON that says sum is 13. Come again? We changed the return statement from a string to a JSON. No, nothing is automatic. So we just made it so that it is more compliant with the convention of how servers and clients communicate. They communicate using JSON. So instead of just putting a string, we want to make it so that if another, okay, actually, let me make this make more sense. Let's take a look at, or let me give you an example of how my Minecraft LED thing work. So I would have created a function, so at app dot get, and I'm going to say slash wool. And when you make a get request, it's supposed to define get color, and it's supposed to return, for example, let's just say it was red. Yeah? So I'm going to go to slash color. Wait, what? Oh, slash wool. And it returned red in a string, right? Now, I just made a GET request to my API, and the response for my GET request is the word red. My microcontroller has no idea what to do with this. I could make it understand it. I can put an if statement that says, if red, make it red. But that's wild. Because then I'm going to have an if statement for every single color. We don't want that. Instead, I had it return a JSON that looked like this. I have 3 fields, R, a G, and a B, RGB. So now, when my microcontroller get the R to be 0, the G to be 0, and the B to be 0, there's no need for an if statement. I just need to take that 0, 0, 0 and put it on the LED, and it can give me black. Because 0, 0, 0 in RGB is black. If it is a case where it returned 225 right here, so, sorry, 255 right here, so, and 255 right here, so, then there's no need for an if statement. My microcontroller get this, and it just put this on the LED, and it can get magenta. Because it's talking in JSON. My microcontroller has code written on it that interprets an incoming JSON that looks for 3 fields, the R, the G, and the B. It take the R, it take the G, it take the B, and it put in an array and make a color value out of it. And just apply that color value directly to the LED. If it say red, it wouldn't know what red mean. Me have to tell it that if it's red, change the color to red. If it's blue, change it to blue. If it's green, change it to green. And then every other color in the rainbow. But me don't want to do that. This handles it for me. Yes, hold on. Yes. You asked a question. What is 255? When we're dealing with color values, digital color values, you can represent any color by mixing R, G, and B, red, green, and blue, at different values. 255 is the most a value can be because it is 8 bits. So 8 bits is F. So the most red you can get is FF, which is 255. And 0 is the least. So this is 100% red and 100% blue. Intensity, well. Yeah, kind of.
Well, yeah. R, B.
Mm-hmm.
If you look at it from combination,
Mm-hmm.
you can have 7 combinations, but you show more than 7 colors.
Good question, or a good point. I don't have to put 255. We can put any number. So I'm putting 12 parts red, 76 parts blue. Or 1 part red, 3 parts blue, and 300, I can't do 300. 255 parts blue. And you just take the numbers from 0 to 255 and put them together and you get a color. Yeah? So it's a combination. Let me show you some examples. RGB. Oops, too much. So look at this. This color is 125376. 12 parts red, 53 parts green, and 76 parts blue, RGB. And it give me this color. That's a nice color. Yeah? So you can try this with Google. The maximum is 255, the minimum is 0. If you wanted all 255s, it would be white, yeah. 255, 255, 255. And that would give me white, yeah. And 000 is black. CCC is light gray. and so on and so forth.
I mean, the cascade style for
CSS, yeah.
That is where I use.
You can use that and you can use something else as well. So yeah, that good? We want to communicate in the JSON format because it's more machine friendly. Yeah? Okay. Let us all right. Let me see. Server client DB. All right, let's take a look at this one. This is not the one I wanted. It is, but not the way I expected it to show me. All right, this one. This one's kind of ugly, but all right. No. All right. Eventually, further on in the course, we are going to get to a point where we're going to be implementing databases in our platform. So we will have a client that is making a request to a server. If that request requires some information that was stored or it needs to store some information, it will store it or retrieve it from the database. So this is just one big hard drive, right? That all the data is stored. The request will come from the client to the API or to the server to store some information. It will store it here. And if it wants it back later, it will retrieve it from here. Yeah? So this is the middleman that just gets all the information or saves the information. Come again? We'll have our clients, our application, which is our FastAPI, and we'll have our databases. We have not done anything with databases just yet, because we don't reach there yet. But I need to show you an example that implements some kind of storage. We're not going to use a database, we're just going to use a variable to store a value temporarily. So we're going to be imitating this, but we're not going to be doing it exactly. Here's what I'm going to do. I need an empty variable. I don't like making them global, because Python weird with global variables. I'm going to make it a variable. I'm going to call it items equal, so I'm going to create an empty array and call it items. Yeah? And what I'm going to do is I'm going to put a couple items in my array. I'm going to manually put them there. So I'm going to say my first item. So items have an item ID. No, let me not put item ID. I'm going to put ID. This one is 1. And this one is name. What is the name of ID number 1? Fridge. And now we're going to create another item. Let's copy this. Copy it again. So now I have 3 items. Let me give them different IDs. This one is ID 2. This one is ID 3. This is a list, yes, a list of JSONs, or a list of dictionaries rather. New, it's like array. Yeah. So this is fridge, this one is TV, and this one is washing machine. That's a very long word. I'm going to put iron, because that's easier. Iron. All right, so I have 3 items. I have it in a list, and my list has 3 dictionaries in it. So here's what I'm going to do. This item list is going to act as my database, a temporary database, or a software built-in database. This is not how we actually implement databases. It's much more complex than this. But this is just a way to simplify it so that you understand how retrieving and posting data to our storage works. So I'm going to write a function that handles an incoming GET request. GET. And I'm going to say /item. And my function requires an ID. So I need to tell it to ask the user for ID using the URL parameters like this, ID, and my ID is supposed to be an integer, because all my IDs are integers. All right? So now I can create a function, call it get item. and it's supposed to take, oh no, wrong place. This is supposed to be here. All right. So what I want to do is I want to look inside of my list called items and check to see if it has an item that has the ID of ID. Was that complicated? Do I need to do that again? So I asked the user to navigate to this path /item, and they're also supposed to specify the ID of the item that they want. I take that ID, I cast as an integer, so I'm going to write some code that will look through my list of items, see if there are any items that have that ID, this ID, and then return it to the user. Yeah. Return, boy, I don't remember what to do this part, you know. I want to return the, I can return the whole thing. I can return the whole JSON. So let me see. I use a for loop. That's not very efficient, but I was going to use a for loop. So for item in items, if ID double equal to item dot, oh not dot, ID, then return, just return the item. Will this work? I hope so. So it's going to create a for loop that loops through all of my items. For item in items. For item in items. If this ID, which is what the user provided, is equal to the ID of the currently iterated item, return the item. How do you do the list? Like this. I think I need to get rid of that. So let's try run this. Go to this. Oh, that's bad. So this item is this item. It is each individual item on iteration. And I'm checking to see if its ID is equal to the ID that the user provided. If it is, return it. Sure. Come again? Hashtag forward. So?
Comment without.
Sure.
Because maybe I use ID number. So,
Oh, so this ID is going to be the same as that ID. So what do we call that? You have to call this too.
yeah, but that.
Oh, interesting.
Yeah.
Oh, hashtag in Python means comment. Yeah. So you can probably use a different symbol. But also, I wouldn't recommend putting a symbol in the name. Just use that. Just use text. So I made a request to get the second item or an ID or item of ID number 2, and it returns the TV. If I made a change, I want to return item 1, it returned item 1. If I want item 3, return item 3. I believe if I try to go for item 4, it return nothing. But we don't like this. This is bad. Oh yeah, but else, that's good. Wait, else? Oh, I get you. Yeah, that's good. That's good. Do what you did. So after my for loop runs, I'm going to put a return error. Item it no dede. Cool? It no dede. And in a case like this, you're correct to make it so that there is a fallback in case you don't find the item. But there's a part here that is being handled for us in a way that we do not want. Let me show you what I mean. So when we make this request, I'm going to show you my development tools. I'm going to show you the network tab. Is network tab? Yes, the network tab. I'm going to refresh, and it's going to capture this response. So this is the request, this is the response. Here's the JSON, and in addition to that, it returned a 200. Is that correct? Should it return a 200? We are making a request to the server for a resource that has an ID 4. But according to my code, we don't have an ID 4. So the message is correct, but the status code wrong. We need to, the reason why the status code wrong is because in FastAPI, as long as you return something, that return will be accompanied by the default 200 OK. You need to be able to specify a status code separate if you want it to be different. So just because you say it not dead, that don't mean FastAPI knows it's supposed to be a 404. You didn't specify what the status code is supposed to be, so it will just send back a 200. So we need to specify that it's supposed to come back with a particular status code, and I don't remember how to do that. FastAPI set status code. Oh, okay. Wait, no, not like that. That's the default. Status code. I think we may need a response object. Yep, we need a response object. That means your code crashed. All right. I think we need to import another thing from FastAPI. So I'll go back to the top of your code. And where you have from FastAPI, import FastAPI, we're also going to import response. The response object allows us to craft a response that is different from the default. So we get to specify the data that it responds with, as well as a different status code if we need to specify a different status code. So we have the response object up here. So instead of returning the JSON, I'm going to return a response, and the response takes two things. It takes, is there a data? A content. It takes a content, content, which is this, and it takes a status code, which is in our case 404. Yeah. And I believe this should work. No. Why did it break? Let's look at our code. Code crash, so we look in here. It says dictionary. Oh, dictionary has no, okay. So, what is it supposed to be? It's not supposed to be content. I think we don't need, I think it's not response. I think it's JSON response we need. Because response handles not JSON objects. So I think I need JSON response. Is JSON response a thing? Not access. All right, hold on, give me a second. Me not remember the part. Hold on a minute. JSON response, FastAPI. Oh, it is JSON response. So why are you complaining? Doggone so. JSON response. And then down here, so we'll call it JSON response. And it takes our content. And now it should work. Am I wrong? Not the name JSON response. So AI tell me JSON response. Oh, it's not from the FastAPI, it's from responses. That's confusing. So we don't take it from here, instead we take it from here. From FastAPI.responses, import JSON response. Now we can use JSON response. FastAPI.responses, import JSON response. So now we can use a JSON response that has a content and a status code. And if I refresh, it should now return What just happened? 8 no dede, and in addition to the 8 no dede, it returned a 404. Yep. All right, it took a long while for us to get there, but we got there. Yes.
Yeah, the server is crashed.
Crashed. Hold on. Oh, item 2. Scroll to your lists. So you have that. Or scroll down. So you say for item in items if ID equal item return. What is not wrong? It's right.
So it's a key or the ID?
Item ID. Scroll up again. In your code. ID right. Reload. Yeah. Refresh the page. Oh, I guess it was just old code that maybe never reload or never save or something.
Use API,
UV current?
UV current and reload thing. It didn't start.
No, I'm not sure. Wait, it seems to be working now. Maybe the code wasn't saved or something. I don't know. Oh, well, I don't know then. Yeah. These things tend to happen. I don't know what exactly happened because I don't saw what you're doing, but it seems to be okay now. Try returning item 3. FastAPI.response, okay. And return 4 now?
No 4.
Oh, there's no 4 for yours. You're supposed to get null.
No.
Again, okay, have a fallback. So you can implement the fallback, yeah. I think it's responses. No, let me show you. Fallback is just a concept. It's just what it's supposed to do if it can't do it. So it's API.responses. Yeah. Back to the top. That's how we respond, a custom JSON response. Yeah, F12. And you go to the network tab. One of the things to note, the way I specified my status code is generally not a very good idea because it would allow me to do something like this. Would this work? 40-40? Let me see if this is going to work. Okay, it doesn't even show because 40-40 is not. Oh, it broke. Hold on. It broke. Key error. 40-40 not right. Okay. We shouldn't specify the raw number. We need to specify a constant. How we get the constant again? The constant is, so we need to import status. So from FastAPI, we import status, and then instead of the raw number, we put status dot, and then you choose one. So we want 404. Yeah, so don't put the raw number. Put the constant. Come again? Because it opens up the possibility of errors. You can put a HTTP request. For example, 404 today means not found. But maybe the people that own the internet or run the internet can change what 404 mean. So if you put 404 hard-coded in your code, it will always return 404 and maybe 404 have a different meaning tomorrow. But if them change it, and because of that change, it spawns a change on our update in FastAPI, you wouldn't have to update your code. You just need to update the library. And then the library will handle the change for you. So you have a variable in your code that's a 404, but it will translate to what it's supposed to actually mean. What do you want to show? Up, down. And if you notice, my return is on the same level as my for, because this runs once the for loop runs to completion. If the for loop runs to completion and this line never runs, it means this never held true. If this never holds true, it means that ID was never equal to any ID inside my list. That means it could not find the item. So it needs to escape the for loop and then just do this. That's why I can have 2 returns in my code, because only one will ever happen. This one will happen if this is true, but if this is never true, this one will happen. No?
Okay, 2 of them can return the same.
2 of them can return. One or the other. Yes. Come again? One more time? One more time. Status code. I imported status from FastAPI. Yeah. Here? Status dot. Oh, status code. Status underscore code is the key. I'll put the status. And we'll end there for today. Tomorrow, maybe we'll look at post requests. So today we covered get requests. Tomorrow we'll look at post requests. Questions? We're good? Come again?
In a couple of applications, we have internal. So we get the operation from the server. Because we put in the numbers. So we basically approve from the server as operation.
Well, we're making a request to the server to perform an operation with these numbers. So we give it the numbers, and we tell it what operation to perform, and it just perform it. We tell it what operation to perform by specifying the path. The path being, in my case, /item. /item in the browser relates back to this function. So if the browser says /item, Python knows it's supposed to trigger this function with that ID.
But this versus a post it doesn't push to the web page.
So it very much depends on what the code says it's supposed to do. Yeah. So I could make it so that a post request, so suppose for instance I say app.post /item. I can ask the user to input an item with a name, and it will add it to my list. Verbal up at the top. We post. We'll do that tomorrow though. We'll do that tomorrow. Any other questions? Okay, end the recording here.